Great. So, am I recording? Okay, great. So, Assalamu alaikum, everyone. Welcome to the 10th tutorial for probability, if I'm not mistaken. My name is Munif Rizvi. I hope all of you are doing well. So, the topics that we had to cover today in this tutorial were mostly just giving you an understanding on how joint probability distribution functions work. How do you calculate the CDF of it? How do you take into accounts in which the two distributions are independent to each other, all of these cases. We're particularly giving you a flavor of joint probability distributions. So I'll try to end this tutorial in between 40 minutes, so that all of you can go on with your assignments and other deadlines that you have. So let's go on with this question. The first question says, consider a sequence of independent Bernoulli trials, each of which is success of probability P. Let x1 be the number of failures preceding the first success, and let x2 be the number of failures between the first two successes. Find the joint mass function of x1 and x2. So the one thing that they've made us apparent, and it's made our life easy, is the fact that we know that these trials are independent to each other. So we know that whatever we have to do, we can easily split these two distributions because we know that they're independent, right? So what do we know x1 as? X1 is basically the number of failures preceding the first event. So agar हमारे पास इतनी एक event, दो event हुए, or this is the point in which we had the x1 event value, be that value be 10 or 11. So basically उसके बाद जो value होगी, let's call it x1 plus 1. That is the point where we get a success, right? So uske hisab se, how do I model this? Because I know this is a Bernoulli trial, I can write x1 as, let's say, I'll call it a. Okay, a can be like value 10, 11, whatsoever, right? A is that value, just where that's our last failure. So I can denote this as number of failures. That's 1 minus p to the power a into p, right? So I've denoted x1 as the number of failures preceding the first success. Now x2 is basically the number of failures between the first two successes. So if I try to extend this, right, what this would imply is that if I take it till this point, x2 is that event, right? So it's the number of failures between the first two successes. So usuli taur pe, if I have to model the joint PDF of this, because I can't usuli taur pe consider it separately up until now based on the information I know. So this is what we're supposed to find is x1 is equals to a. I'll call x2 value, I'll call it b, right? So x2 is equals to b. Now, because they've told me the fact that these two events are independent of the other, I can denote this as this. I can separate the two essentially. Now, the idea is I've written down a general form of the Bernoulli distribution, right? So I'm just gonna do the same here, and this will be multiplied by p ka kya hoga? 1 minus p to the power b into b. Sorry, into p, my bad. So essentially what the probability will now be essentially is p square into 1 minus p to the power a plus b. So that will be the probability mass function of x1 and x2. Note, I could only do this had this been because these are independent Bernoulli trials. Had they not been Bernoulli trials, then I couldn't separate it. I would have to use another approach, right? That is where independence comes to our advantage, so to speak, because we can easily write this in this form. Any confusions? If not, in the meanwhile, I'll go to the next question. Oh, you feel free to sort of text me any questions if you have any on like the chat. Take, I'll give you guys 10 seconds to read this. The joint probability density functions given by this. Find p is x then s. Okay. So this question is a bit tricky in the sense that, okay, I know f is e to the power minus x minus y, and I know the limits for this. If I have to find p x less than y, I have to be, the only thing I have to be careful of, again, I have to find the CDF, right? So that's essentially the integral of both limits. But the one thing I have to be careful of when I am noting this down is that I just have to be careful in terms of the limit value I'm using for either or, because they've said that x is lesser than equals to y. So based on that, I have to make sure either my y limit is adjusted to this or my x limit. Now note the general form of an PDF function, or like no, not a PDF function but a CDF essentially, is these are the limits for y, sorry, these are the limits for x, these are the limits for y, and I write this f, whatever the function I have, with respect to dy dx. Now what I'm more comfortable with is the fact that because I have y here first, right? The first thing that I have to integrate out is y. So I prefer dealing all of these cases with respect to y. Now, I know for a fact that the largest, whatever value of x I have to use, it has to be lesser than y. So based on that knowledge, what I'm going to do is I'm going to fix this limit as, it can be denoted as the lowest value. What's the lowest value of y that it can have? It can be x, right? And it can go to a maximum value of infinity, because I know whatever value of x I use, it will always be lesser than y. So to account for the fact that that x is lesser than y, I can denote it as this, and x will be the standard 0 to infinity. Okay, and what's our f here? That's e to the power minus x minus y dy dx. Now, how do I go about this? I'm going to integrate this with respect to y. So e to the minus x minus y, तो यहाँ एक minus sign आ जाएगा, and everything else will stay the same. And the limits will be from x till infinity. And after whatever integral value I get, after I get the limit values, I have to later integrate this with respect to x. What I'm getting a question, why have we denoted x? Okay, so the reason why we're using x in the denominator is the factors are what the question is asking us is find the probability for all cases for which x is lesser than equals to y. The thing is, I have to find a relation between x and y somehow, right? I could have also written this as, अगर मैं x की limits में लिख देता as till it will go from 0 till y, because what's the lowest value of x? It can be 0. What's the maximum value of x that it can have with respect to y? That's y. So I could have also written this with the limit 0 till y, and the y limits could have been 0 till infinity, right? I could have done this, but what I'm more comfortable with is just get it done with what the internal limit is as well. You're more than welcome to do whatever you're comfortable with, right? But this is just the standard notation that I like to follow. Now, if I solve this, infinity, 1 upon infinity, that's 0, minus minus plus x minus x minus x, that's minus 2x, so minus plus ho gaya. So this will be minus e to the power minus 2x. Okay, again, why minus? Because 0 minus whatever value I have, ठीक है, एक तो वहां से वो हो गया, and because वो पहले से minus था, तो that takes care of itself. So I inputted y की value, I inputted it as x, so minus x minus 2x. Okay, so now I have to integrate this with respect to x. So this will be wait, this should be plus. This should be plus, because 0 minus से वो plus हो गया, right? So now when I'm integrating this, right, minus sign नीचे आ जाएगा, so minus 1 upon 2 e to the power minus 2x, and this will go from 0 till infinity. So infinity, I input that in, that's 0, minus, so that's 1. e to the power minus 2 0 into 0, that's 1, right? So minus minus plus, so essentially what this is 1 upon 2 plus 1 upon 2, right? So I find I've done this, right? So again, please be very careful with the limits that you use. Now in part B, they said x is lesser than a. So there's no relation between x and y now. I only have to cater to the x limit that I'm using. I'm going to do this working here because just so I have all the information available to me. So, okay, so what do you think should the limits for x be? Can I have some volunteers, please? Like, just tell me what are the limit values for x. Y, it will be the same, 0 till infinity. Some are saying 0 till infinity, some are saying 8. Okay, so I'm getting 3 answers. So essentially, you've mentioned all the 3 limits that can be possible, but the idea is what's the maximum value of that x can have based on the condition that we have, that's a. And what's the lowest value by default? 0, because they haven't mentioned any information regarding this except for the limits that they mentioned at the start. So it will go from 0 till a. These are your x limits, and y will stay the same as 0 till infinity. E to the power minus x minus y dy dx. Now we did this before, right? So this is minus e to the power minus x minus y, minus sign on it. This will go from 0 till infinity. With respect, again, values I have to input with respect to y. This will be infinity, that's 0. When I put 0, that's e to the power minus plus, so that's plus e. So this will be e to the power minus x. Right, and now I have to integrate this with respect to x dx. So this will be minus e to the power minus ex with the limit 0 to a, and this will be minus e to the power a minus plus 1. So this is 1 minus e to the power minus a. Okay, pretty standard question. Again, if you know how to cater to the limits, the actual computation bit is very easy. And again, you have the leverage of having a calculator to do these calculations for you if you know how to use like the calculator well as well. Any confusions? If not, I'll move to the next question. Take, I'll give you guys 10 seconds to read this. So I'm reading the question as well. I'm noting down all the information that's relevant to me. Okay. So I know the probabilities for someone buying an ordinary television set, a plasma television set, and just browsing. What they're saying, if n is 5, say if 5 customers enter the store, what is the probability that he will sell exactly 2 ordinary sets and 1 plasma set? So by default, that also means that the number of people that are browsing, that's also what, 2? Yeah, 2. Okay, so I know for a fact that this is a multinomial distribution. Do you guys know why this is a multinomial distribution? Is there any concern on why this should not be a multinomial distribution? Yes, correct. So someone said in the chat that the outcomes of the experiment involve multiple variables. Absolutely, that's bang on. Basically, that is the definition of a multinomial distribution, in which you have various outcomes involving 2 or more variables, right? If you have a 2 variable multinomial, that's not a multinomial, that's a binomial, which you are aware of. So essentially, the distribution layout that I have to follow is a multinomial one. So I know this will be 5 factorial upon 2 factorial into 1 factorial into 2 factorial. And with respect to their own probabilities, that will be 0.45 into square, because यहाँ पे 2 था, 0.15 into 1 and 0.4 into square. And it's a very simple question, just importing the values in the equation. I have it written down that this is 0.145. I hope there hasn't been any confusion in this case. Essentially, the one thing that you should be aware of is the relation with joint probability distribution is, I have simply just written down how I would do it. Halake, what they've done is, assuming you have 3 different events, right, and all 3 can happen at the same time. So essentially, you buying an ordinary television set, a plasma television set, or just browsing, these are 3 separate events. And the idea is, because these are not independent, I can't separate them into px, py, pz. Right? I cannot do this. I cannot do this at all. So how do I find a way to sort of, in this particular problem statement, how do I find a relation between the statement and the relevant distribution I have to follow? Because these are numerous outcomes and with multiple variables, 3 variables in fact. So because there are multiple outcomes, I can use a multinomial distribution. That is the definition of multinomial distribution. And hence why what I've done is, so basically this is POT, PPT, and PBR, right? And I have written this down in this form based on the values that I have been given. Okay. Had this been 2 cases, you could have just simply used a binomial distribution. Okay. If they just said people can either buy an ordinary television set or just a plasma television set, you're more than welcome to use a binomial distribution. Okay. But keep in mind that there will be cases in which you have a joint distribution, but they're dependent to each other. The outcomes are dependent to each other because your sample size is defined as such. You have to cater to all 5 individuals. So उन cases में you have to think of a distribution that would work. As people like say can ask you a question regarding Poisson distributions regarding this, for example. And I'm just giving you one example of how it can be asked. So I'm moving to the next question now. Take a question for, I'll give you guys a minute to read it. No, 10 seconds. Okay. So the key information I know based on reading this question is that they're independent. Their timings are independent. So whatever distribution I use, I know for a fact that those 2 are independent. I can separate the 2. So I am going to denote this as, they've told me they are uniformly distributed. So I'm going to, for my convenience, I'm going to denote M as X, right? And let me write this better. And women as Y, right? So X can be defined as a uniform distribution between 12:15 till 12:45 or दूसरा क्या था 12 to 1. So I'm going to denote this in terms of minutes for my convenience, right? So this will go from minute 15 till minute 45. And for women, the uniform distribution is such that it will go from 0 till 60 minutes, right? So 0 till 60. It's easy for me to define it because I can denote this as a simple number line. This is 15 to 45, but this is 0 to 60, right? So 0, 15, 45, 60. It's easier for me to denote the sort of times, right? Find the probability that the first to arrive waits no longer than 5 minutes. So the thing is, I don't know who arrives first. Either a man could have arrived first or the woman could have arrived first, right? So one good way to represent this is using the absolute function, in which I can denote this as x minus y absolute. Basically, if x is greater, so say a positive है, but if y is greater because of the absolute function, ठीक है, and I have to limit this to the inequality, it shouldn't be greater than 5 minutes. So I model this. Now, how do I sort of write this down? Because I know for a fact that these are क्या कहते हैं, uniform distributions, I can separate them. Now, note, based on this condition, my limits would be very different from what one would expect it to be, right? Abhi, I'm just going to write कि होना क्या चाहिए, कि these should be your x limits, these should be your y limits. Fx is basically the probability distribution of like the male, and this will be the probability distribution of the female, dy dx, right? So now this is denoted as, it's a uniform distribution, right? So 1 upon 45 minus 15, so that is 1 upon 30. Uniform distribution. हमें बस एक small f की चाहिए, probability distribution, so that is denoted as 1 upon b minus a. And similarly for this is 60 minus 0, so that's 1 upon 60. So I know for a fact that whatever value I have, this will be like whatever limits I use, this is the f function that I'll be using. And again, I've written it as this usuli taur pe. What this implies is fxy. This is what's supposed to be written here, but because these are independent, I've separated them as fx, fy. I hope that's clear. Now, I have to be very careful of the limits I use. Now, I prefer making whatever is on the inside as a subject, so I'm going to make y as a subject. So this can be defined as two cases, right? In terms of the limits, x minus y is less than 5 and x minus y is less than minus 5. So so my limits now, if because I'm keeping y as a subject, I'm going to input the relation limits into like with respect to y. So this will be y should be greater than x minus 5. I'm sorry about my writing. And y should be lesser than x plus 5. Okay. Perfect. So now I know what the limit values I'm supposed to use. It should be greater than, no wait. Yeah, it makes sense. Y should be lesser than x plus 5 and y should be greater than x minus 5. Perfect. So now I'm going to input the limits here. For x, I'm going to denote this as 15 to 45 because these are the limits for x. And for y, I'm going to denote this as x minus 5, x plus 5. Wait, I just realized one mistake I had made. Can anyone tell me what mistake was this? Actually, it's not apparent here, but had I used other limits, it would have been a problem. So the thing is, you have a uniform distribution such that it goes from 15, x goes from 15 to 45 and y goes from 0 to 16. Had I made x the subject, it would have caused a problem because that would imply that there is a value. Agar मैं कहूँ कि x should be greater than y plus 5, but y could be a value like 55, like 55 till 60, right? That does not encompass like the x distribution, right? So usuli तौर पे I need limits that sort of are an intersection for both. I'll draw it. I'll make it here in the diagram I made. So essentially what I'm trying to say is it worked out beautifully right now because this worked out by luck, just by the way, that the limit, what I made the subject was something that could work in this case. But essentially the thing is, had I made x the subject and it was something, for example, x is greater than y plus 5, y could have been a value of 55. And because it's 55, the range would have been till 55 till 60, like these values here. But usuli taur pe x doesn't stay till this point, till that wrong, right? There's no intersection. How can they meet if y only stays for 15 to 45? So usuli taur pe, if I had read the question better, I should have known that I could have only made y the subject and not x. I hope that's clear. Again, I want an intersection point. I think that's why they mentioned these limits, like 15 to 45 and 0 to 60. Otherwise, I wouldn't have been able to do it. Right? I hope that's clear. So I realized this mistake when I looked at what limit values I'm supposed to use. Now, f is what? F is 1800, and with respect to dy and dx. So I can take 1 upon 1800 out because there's no variable in that case. 15 to 45. So yahan pe now there's x minus 5, x plus 5. This is 1 dy dx. This will be y, or y pe you have, let me just confirm. Yeah. So I'm just going to go over my working again, but I would also encourage you guys to do this working as well. I give you guys 5 minutes to tell me what the final value should be. Okay, so what it should be is x plus 5 minus x plus 5. These are the limits, and this equates to what? 10. Right? Right. So now I have 10. Wait, my computer is causing me problems. I'm sorry. So now I have 10. Now I have to sort of input the x limits here. So I have 10, and this will be, so this will now integrate this with respect to x. So this will be 10x with respect to 15 to 45. 450 minus 150, that's 300. So 300 upon 1800. So that is, yeah, 1 upon 6. Is this the answer you're getting? Because I think this is what the answer should be. Again, it's a very basic calculation. I don't know why I got confused, but like this is what like the answer should be. Great. So other people also got this answer. Thank you. So we're done with part A. What's part B? What is the probability that the man arrives first? Okay, so they've made, so essentially what they've done is that they made my life easy. So they've defined the event as X was males, right? So the time for females, or the time for the female arriving is more than the time for the male to arrive. So I can denote it as this. Again, we're dealing with respect to minutes, right? So again, I can take either approach. I prefer making y the subject. So x की limits में ये रखूंगा, y की limits I have to fix. So instead of it being, okay, y is the greater value. So the lowest value of y can it have with respect to this relation is x, and the greatest value it can have is 60, right? Because it's uniform distribution from 0 to 60. I'm going to plug in the limits again. These are the limits, and the f function is 1800 dy dx. I'll do this very quickly now because I'm pretty sure all of you know how to do this. ये 1 होगा, अगर मैं इसको इंटीग्रल को बाहर ले जा रहा हूँ तो ये 1 होता है, right? So I'm going to input 60 minus x into this. So अब मुझे 60 minus x का इंटीग्रल लेना है from 15 till 45 with respect to dx. I hope there's no confusion because I did this very quickly. 1 है, right? 1 का integral क्या होगा with respect to y? That's y. In y I have to input the limit 60 and x, so 60 minus x. Okay. Now I'm integrating this with respect to x. So this will be 60x minus x square upon 2. और उस पे मुझे लिमिट्स इंपुट करनी है 15 over 40, 15 and 45, and I have to divide the whole thing by 1800. So that is what my answer should be. I have the answer written down. So I'll let you guys let me know what the answer is. Yeah, the answer is 1 upon 2. Perfect. You just simply have to input the values in. It's very basic. Okay. So I hope there is no confusion as to how to deal with these cases regarding joint distributions now. Again, please be careful of the mistake I made at the start, because it can happen to a fair number of people. I hope it doesn't, but it can happen. Right? You have to be very careful with respect to the limits that you use. Usuli तौर पे there's nothing given in the question as to give you an indication of what limits you have to use. But the idea is you have to use your logic in the sense that you know that they have to intersect. And if I make y the subject, there is a possibility that if I make x the subject, there is a possibility that y could be a value that is simply not in the sample space of x. Okay. So I'm moving to the next question now. This seems like a pretty basic question. Show that f is equal to 1 upon x. Okay, so the limits are in relation to each other. That is something I have to be careful of. Assume, so the first thing that I have to do is show that fxy is a joint density function. How can I do that? The idea is, if it's a joint density function, if I input all of the limits that I've been given of x and y and see if the entire thing adds up to 1 or not, right? So what I have to do is, these are your x limits, these are your y limits, f dy dx. Usuli taur pe, for the entire integral or the entirety of the limits, it should be equal to 1. Now, because this is a conditional sort of limit, right? I have to be very careful with respect to what limits I use. Now, I prefer, again, making use of y in this case. So I'm going to denote x as what the endpoints, right? 0 to 1. And for y, because y is 0 is less than x, 0 less than y less than x, I prefer writing it as 0 less than x. Okay, and again, this is the y limit. Now, f is 1 upon x. Right? If I integrate this with respect to y, so that's y upon x. This पे limits मुझे डालनी है 0x. Again, ये हमें y में डालनी है. So that will be just 1. Yeah, that will be 1. Ab 1 पे I have to input 0 to 1 with respect to dx. That is also equals to 1. So because both the integrals, the limits that I've put in, they add up to 1. So I know for a fact that this is a joint density function. Now, to the actual bit of the question. So the question says, find the marginal density of y. When they say marginal density of y, what they means is you integrate out x or with the limits of x, and then see what's whatever expression you have remaining, that's the marginal density of y. Essentially, you integrate out the other variable. Now, I'll let you guys do it if you want. So this is pretty basic. So fy is, it will go from, again, 0 to x, because wait, this is fx, because I'm inputting y key limits now. So I'm essentially finding the marginal distribution for x, and 1 upon x here with respect to dy. I calculated this before, and that was 1. Yeah, and this is with respect to 0 less than x less than 1. So I'm done with part A. Now for part B, now for fy, I have to use y key limits. Now, what are y key limits? Sorry, what are x key limits? The thing is, I just realized one thing. This is 1 upon x. Agar if I use 0 to 1, the thing is 1 upon 0 is infinity. Usuli तौर पे I'm not going to get the right answer here based on that. So if I use the standard 0 to 1, right, जो हमें बताया हुआ है, I'm not going to get a right answer, so I can't use this. I'm going to get a math error because of it. So one thing I can be clever with is know the fact that it's 0 less than y less than x less than 1, right? I'll just confirm it from here. Yeah, 0 less than y less than x less than 1. So I'm going to be a bit clever here and revise the limits as y till 1. I know for a fact that अगर मैं खाली with respect to क्या कहते हैं y करूंगा, I'm not going to get a right answer. Because अगर with क्योंकि it's there's no क्या कहते हैं variable associated in the f function. It's just a value like 1 upon x, right? So usuli तौर पे I know I'm going to get a math error if I use 0 to 1. So I have to use y here somehow. And based on this relation y less than x less than 1, I can input the limits as 1 and y. उस पे मेरे साथ क्या होगा? I have to limit out x, right? I have to integrate this with respect to x. 1 upon x किसका integral होता है? Log function का, absolutely. So now I have a log function with respect to y, and this will go from 1 till y. What's log 1? I think that's 0. I'll just confirm, but I'm 100% sure it's 0. Yeah, it's 0. So this is 0, 0 minus log of y. So essentially, now I have an expression for this. Okay, and I know कि 0 y की limits क्या है, 0 less than y less than 1. Okay. So you will encounter cases where you might get math errors, especially when you're dealing with exponentials and some of the limits are 0 or infinity. So you will encounter cases, but they will give you a clue in terms of the limits that you're using. Okay. So now for part C, they're saying find the expectation of x. Expectation of x is pretty simple. What's f? Usuli तौर पे it's you input the limits of x that you have, right? You input the limits of x that you have, and you have your fx function, and then you multiply that with another x if you want the expectation, right? It's a pretty standard equation, and you're going to do the same for y. हमारी fx की वैल्यू क्या थी? 1 थी. So 1 into x, that's 1, 0, 1 x dx. This will be x square upon 2, x square upon 2 with the limit 1, 0. So that's 1 upon 2. Pretty standard. Now with expectation of y is the same formula, but let's see what ideally I'd want to see if I can directly do it with respect to 0 or 1, right? 0, 1, y. What's fy? Fy is a minus log of y. Minus sign to बाहर जा सकते हैं. So log of y. Y log y with respect to dy. Now, if you've covered integration by parts in calculus, you know I can solve this very conveniently. Right? I hope all of you are aware of integration by parts. So सबके अपने अपने तरीके होते हैं integration by parts के, but I know u is log y, du is 1 upon y dy. I'm going to denote dv. बाज़ लोग v करते हैं फिर v integral लेते हैं. I prefer dv equals to y, so that implies v should be equal to y square upon 2. Now, by integration of parts, I can just directly input this in the equation, and that will be log y into y square upon 2 with the limits 0 to 1 minus integral of the integral I have to find out still, y square upon 2 into 1 upon y. I have not written this before. I just calculated this, so please let me know if I've made an error. I would like to think I've done this. I've done this correctly. So importing the limits, log 1 is 0, log 0 doesn't exist from what I'm aware. So the idea is, I think this can be simplified later on to minus 1 upon 2 integral of 0 1 y dy. Now if I just input the limits here, this can be denoted as minus 1 upon क्या कहते हैं 2. Let me just confirm whether this is the right answer. But please do let me know if I made a calculation error here. I have a feeling I have. No, this should be, yeah. I realize what error I made. So, usuli taur pe, yeah, the error I made is this should not be 1 upon 2, balki this should be 1 upon 4 because I forgot to divide it by 2. ठीक है. Basically, y का इंटीग्रल क्या होता है? y square upon 2. Y square upon 2 पे अगर आप लिमिट्स डालें, that's 1 upon 2. 1 upon 2 into 1 upon 2, that's 1 upon 4. Usuli taur pe is minus 1 upon 4, but because we want the expectations, it's 1 upon 4. Okay. Again, please do let me know if it's causing any confusions. We can also go over this after the tutorial as well. Okay, so I can stay back after the tutorial. Okay, so I'm now going to move to the last question. So it's basically an adaptation of the question that we've been doing for the past 2 questions now. So the first bit is we need to see if x and y are independent. Also, this is the last question of the tutorial. We first need to see if x and y are independent. So what's the check for independency? The idea is fx comma y should be equal to fx into fy. That is the case for independence, right? Now, let's first calculate fx. I have to integrate out y, right? So f x y with respect to dy. So this will be x plus y now. So integral of x plus y with respect to y, that is xy plus y square upon 2 plus y square upon 2, और इस पे लिमिट्स डालनी है मुझे 0 till 1, and that is x plus 1 upon 2. ठीक, I have f because these are symmetric, right? मतलब x plus y और वही चीज कटी और लिमिट्स भी वही हैं, तो सूली तौर पे यही आंसर होगा मेरा fy के लिए, but with respect to क्या कहते हैं with respect to y. So this would be y plus 1 upon 2. Now, are they the same? X plus 1 upon 2 into y plus 1 upon 2. This is not equal to x plus y. So उस sense में these are not independent. Okay. Very simple check. Input the limits and find fx, find y, fy, see if it's equal to fxy. So I'm done with part A. Now part B is saying find the density function of x. Okay. Wait, I've done fx. So basically I've done part B. In my check for part A, I've already done part B, because part B says find the density function of x, so that's fx. तो वही अगर दोबारा आपको करना है तो वही कर ले, लेकिन essentially it's to check for independence is the same thing. There should be x plus 1 upon 2 और limits जरूर डाल दीगा, it's 0 less than x less than 1. Okay, so part C is find the probability of x plus y is less than 1. Okay, how do I do this? I'm going to make y the subject, so I can denote this as 1 minus x. So for whatever value of y I use, the maximum value of y that I can have is 1 minus x. It can't be greater than 1 minus x. So I am just directly going to input this into the fxy function. So x की limits क्या होंगी? It will be the same, 0 to 1. Y की क्या limits होंगी अब? Because the greatest value is 1 minus x, so 1 minus x वो यहाँ आएगा, और the lowest value is again 0 जो हमारी limits थी. fxy is x plus y and I have to integrate this with respect to dy and dx, right? So first with respect to y, that's xy plus y square upon 2 और उस पे मुझे ये limits डालनी है. Let me push this down a bit. और फिर बाद में मुझे इंटीग्रेट करना होगा इसको with respect to x. So with respect to y, so this is x into 1 minus x plus 1 minus x square upon 2. 0 तो basically cut ही जाएगा. And now I have to, this is the function I have to integrate this with respect to x. Again, this should not be difficult. You can separate this, but I would encourage you guys to do this if you want some practice. अगर आपको खुद करना है. So x minus x square plus 1 minus x square. अब इसका इंटीग्रल है. This is x square upon 2 minus x cube upon 3 minus, क्योंकि माइनस साइन अंदर है तो ये कट जाएगा. ओह नो, ये तो इंटीग्रल है, राइट? हाँ तो so this is minus 1 upon 4. ठीक है, तो ये 6 होगा my bad. ठीक है. So now I've integrated this and I have to input the limits as 0 and 1. I have written this down. The answer should be 1 upon 3. But do let me know if this does not work. And with that, I guess we're done with our work with the tutorial. I will upload one more question. There were a total of 7 questions, but basically that question is for you to practice. It's the same as question 6, the one we've done, but with just a different function value that we have. So you're more than welcome to like practice it, and if it's causing trouble, you're more than welcome to email me, and like we can go over this in my office hours, for example. But in terms of the content, that's pretty much it. So I'll stop the screen share now. Thank you again, everyone.